Hello students and seekers of truth. In this video we are going to look at another arc length example, except this time we're given a function of x in terms of y. Okay? And so the idea is the same. We are going to integrate from a to b of the square root of 1 plus, and this part is a little bit different. Instead of being dy dx, it's going to be dx dy. In other words, we are going to treat y as the variable and x as the function, and then square it, and then integrate with respect to y. Okay. Now, sometimes with calculus, it's actually the algebra or the graphing that is most difficult, because we need to know what this function is supposed to look like. Well, if you rework this a little bit, you end up with x squared is equal to 1 minus y squared, and that means x squared plus y squared is equal to 1. So hopefully your geometry teacher taught you well, and you can recognize that this is a circle centered at 0, 0 with a radius equal to 1. So it looks something like this. Now we only want, we only want the function that matches this description. So, and it's only from y equals negative half to y equals positive half. So, this is 1 up here, and so these tick marks here are negative 1/2 and positive 1/2. So we only want this arc here of the curve. Now you may say, why not the other side of the curve? Well, it's the same thing. Whether we find the curve on the right or the curve on the left, it's the same thing. This particular function refers to the curve on the right because this is the positive square root, not the negative square root. But the answer would be the same once we worked out all of the math. Okay? So this the trick is we got to take the derivative, and this will give us a good chance, a good opportunity to practice and review some of the old things that we did before. So the derivative, dx over dy, in other words, x prime, treating y as the variable, is equal to, and you can think of this as the square root of 1 minus y squared is really that expression, that quantity, to the 1/2. So the derivative of that is 1/2 times 1 minus y squared to the negative 1/2. So the power rule here coming into play. And also, don't forget to multiply by the derivative of the inside function, which is negative 2y. So the 2 and the half cancel, and now we end up with negative y over the square root of 1 minus y squared. Okay, so this is dx dy. So once we take this result and substitute it into this function or this formula, we get the integral from a to b of the square root of 1 plus. Now all of this whole thing here gets squared. Okay, so I'll write it out here. I don't want to skip too many steps. Dy. So this is going to equal the integral from a to b of the square root of 1 plus. Now when we square this, the negative y becomes a positive y squared, because when we multiply two negatives we get a positive. And then the denominator is, we're going to square the square root, so we get 1 minus y squared. Okay. All of this times dy. Now this integral is a little bit gnarly to evaluate, so I won't get into it, but we can just let and I shouldn't say from a to b. This is very silly of me, not from a to b, because we already know what a to b is. It's from negative 1/2 to positive 1/2. Okay. So from this point on, you're free to let your calculator do a little bit of work. We've already done an example where we worked out all the gory details. So if you put this into a calculator, this is the answer that you should get. Actually, I changed my mind. I don't want you to just plug into a calculator. If you are allowed to use a calculator, by all means go for it. But I'm going to show you a better way to just continue working on this and just to review and exercise your skills a little bit. The answer comes out to be pi over 3. But I want to show you where this really comes from. So this is the square root, and I am going to get this into the same common denominator. So this is 1 minus y squared over 1 minus y squared plus y squared over 1 minus y squared dy, which is equal to the antiderivative from negative half to positive half. And you can see that I can combine these two fractions, and I will get the square root of 1, because the negative y squared and the positive y squared will cancel. And in the denominator, I get 1 minus y squared dy. Now, keeping everything else the same, I can separate this square root into the square root of the top and the square root of the bottom. And the square root of 1 is just 1. In the bottom here, I get the square root of 1 minus y squared dy. Okay. At this point, I hope that a light bulb or a bell or something, whatever is the proper figurative term here, triggers for you, because this antiderivative should look pretty familiar. It turns out this is in fact equal to the sine inverse function of y, evaluated between negative half and positive half. So this is equal to the sine inverse of 1/2 minus the sine inverse of negative 1/2. Okay? And the sine inverse of 1/2 is pi over 6. The sine inverse of negative 1/2 is negative pi over 6. So all of this comes out to be exactly pi over 3, which, had you used your calculator, you would get about 1.04 and some other decimal places. 1.047. Let's make sure we go out to 3 decimal places, especially if you're taking the AP exam. Okay. So there we go, an example worked out from the beginning through the end, using nothing but our understanding of arc length and our widths, and technically we could even use a series to estimate this one without really using any fancy calculators. Okay, but the main idea is finding arc length. In some examples you get to use a calculator, in some examples you don't. I did 2 examples here in these 2 videos that show you how to work this without a calculator, because I'm sure if you can do that, then you can definitely do it with a calculator. Thank you for watching. As always, work hard and ask for help when you need it. Have a wonderful day.